Hello guys, you're welcome to this brand new series on reverse engineering for beginners. So in this video, I'm going to be introducing you guys to the tool we're going to be using for reverse engineering throughout this series, and we're going to be using the coder. And throughout this series, we're going to be learning about reverse engineering and how to crack, software applications and stuff like that. And we're going to be using coder for that. So right here we're on the website. As you can see, this is the website coder.re, but I'm also going to leave a link in the description so that you can go here and download coder, and it's available for all the major platforms. We've got coder for we've got coder for Windows, Mac, and Linux, so you can download that. But as far as I can see, I can only see the coder version for Windows here, for Linux here, but I'm pretty sure they've got coder for all the platforms. Okay, I'm not sure about Mac, but we've got coder for Windows and Linux. I'm very sure of that. Okay, so we're gonna be using coder, or if you're familiar with the command line tool Radar 2, you can also check that out. So this is built on top of Radar 2. Radar 2 is a command line tool. It's also a reverse engineering framework, but coder builds on top of it by providing for us a graphical user interface, so that makes our work a lot easier. Right, so that's that. So make sure you click on the download button. I'm running Linux and I've already downloaded it, so I'm not gonna do it again. So once you've downloaded the coder, then we can get started with this video. So the next thing we need to download after that is gonna be the Crackme file we're gonna be playing with in this video. Alright, so as you can see, this is the link. I'm also gonna leave this link in the description so that you guys can find you can download this Crackme. And as you can see, this was written in assembler and is available for Unix or Linux. So if you're running Windows, then you're probably gonna have to look for another Crackme or something, but the general idea is gonna be pretty much the same. I'm running Linux here, so obviously I'm gonna be this tutorial series is gonna be geared towards the Linux users. So if you don't have Linux, you should probably install Linux, and you can follow along with this tutorial. Alright, so the first thing I want you to do is just find the link in the description, and you can download this Crackme. I also already done that, and so once you finish downloading this, make sure you put a password when you want to unzip the file. So you're gonna get a zip file, and so you make sure you set the password. Once you request for password, the password is simply crackmes.one. There is no HTTP or whatever in front of it. It's just crackmes.one. I'm also gonna leave a link, the password, in the description so that you guys can find that in case you forget. So it's crackmes.one. That's the password in order to unzip this file. Alright, so now the next thing I want to do is fire up the coder. This is what we're gonna be, so I'm gonna open that up right now. And if you're on Linux and you cannot execute this file, what you should do is to quickly go over to the terminal. Let me open up a new tab here, and just a minute. So I'm gonna go to downloads, just like that. So what you want to do is type in chmod +x, and then you're gonna do coder and the name of the file. Okay, so once you cd to where the file is, open up your terminal, cd to where the file is, and then you can just type in this command to make sure that the file is executable. Alright, so once you do that, you should be good and you should get this screen. Alright, so you might not get this screen if you're running if you're opening coder for the first time. You're gonna get the light theme, but I already customized this, and so that's why I can find the dark theme right here. Okay, cool. So right now what we're gonna do is so we're gonna go back here, and I'm just gonna click on select new file right here. Just select, and you can find Nazem_crack right here. Wherever you save the Crackme file, you're just gonna click on that and then click open, and then select it and then click open. And that's gonna just leave everything by the default, but let me quickly explain what this is talking about. So you can enable or disable analysis, and analysis simply allows coder or Radar 2 that's working in the backend to help you analyze this binary so that it can help you annotate flags and some other things like that. So it can also help you identify functions. Basically the analysis is to make your life easier when you're reversing this software. So it's usually good to just turn on analysis, or else the binary you're working on is very very large. But for this program, it's a very small program, so we're just going to enable analysis right here. As you can see, it's just a level 1 program and it's for beginners. Alright, so as we do more Crackmes in this series, we're going to be working on Crackmes that are with higher difficulties, and we're going to be learning more about that. So let's come back here. The loading write mode simply allows us to modify the binary. So say we were writing a program, we were trying to crack this binary by getting the by changing the behavior of the program. So if I were to check this loading write mode, then I'll be able to change the behavior of the program by changing the assembly code inside of the program. But in this video, we're not gonna be doing that. Okay. I also don't want to load the binary information because that's not necessary. Alright, so I'm gonna leave everything else as is, and we're gonna be explaining all this as we go, but for now I think that's enough. And but before I continue, I want to quickly run the program just to make sure that we get what this program is doing right here. So what I'm gonna do is I'm gonna try to run this program, and as you can see, the prompt here is enter your password. So I'm gonna enter like a password, and as you can see, it says wrong. If I try to enter my password again, another password, and it says wrong again. So so obviously we need to get the correct password in order to get the correct message, something like that. All right, so yeah. And I forgot to say that at the beginning of the video, the requirement of this video is that you have an experience with assembly language. Alright, so you must have experience with assembly language because mostly we're going to be working with assembly code throughout this video series. So make sure you have knowledge of assembly language. So once I click OK there, as you can see, it does the analysis and it takes me right here. Alright, so let me explain quickly what all this is before we get started. So what you see here is the functions view, and this is where all of the functions that the radar 2 analyzes is going to put all the functions right here. As you can see, it analyzed only one function, and if I go back here, you're going to see that this program was written in assembler. So probably the writer made only one function, and as you can see, so that's the only function it was able to analyze and put. So it's going to put everything in the functions tab right here. And as you can see, this huge space here is gonna be it can be toggled using all of these tabs. And if you go to the dashboard, you're gonna see that you're gonna get an overview of information about this file. So you can see the file, the file path, the format. This is an F64, it's 64-bit, and you can see several information about the file. Here it says C, but this program was actually written in assembly language, but I think it was linked with a couple of C libraries or something. I'm not even sure of that, but anyways, it says C for the language here. That's probably wrong. But so it's gonna try to analyze the file and give you information about it, and so you can check out the information that this gives you right here. So that's that. So you can also see the hashes, entropy. So if you need any information about all this, and you can also see the analysis info. As you can see, like I said earlier, it analyzed just one function. What the hell? Get out of here, get back here. Alright, so you can see it analyzed just one function, 6 cross references, 1 call, and there are 2 strings it found in this program, 2 symbols and 0 imports. So imports are like functions that you use from other libraries. So that's gonna be the number of imports, analysis coverage, code size, and stuff like that. So that's the dashboard. So for the strings tab, it's gonna show you all of the strings inside of the program. And so yeah. We're going to talk a little more about strings maybe sometime, maybe before this video ends, or maybe in the next video, I'm not sure. Alright, so imports, like I told you before, so the imports tab is going to contain all of the functions or methods used from other libraries. No other library methods are used here, so there's nothing in the import section. So search allows you to search for whatever you want to search for. You can search for assembly code, you can search for string, hex, ROP gauges, 32-bit values, and such like that. And okay, so you can also search in several sections, and We're gonna be seeing now some of this work, as we go along throughout this tutorial series. And here is the disassembly view. Okay, so disassembly view is where you're gonna be seeing the actual code that has been disassembled for you by Radar 2 or Cutter as it is. All right, and so you can see this is where the RIP currently is. This is the beginning of the function, and so it also is gonna help you give some of these things names, as you can see right here. So all this is part of the analysis, and we're gonna get back here in a minute just after I finish explaining what all these controls are and such. Alright, so going back to the graph view, you can see here that the graph view is simply just gonna show you functions, and it's gonna help you put them in a graphical sense, in a way that you can actually understand what is going on. Like for example, this is like a block, and this is where the code branches. So it's like if something happens, it goes here. If it doesn't happen, then it goes to this place. So you can see what happens when something comes here, and what happens when when everything goes wrong, just like this. All right. And I like to use the graph view a lot, but sometimes it basically only analyzes functions, as you can see here. So if it's not enough, if it's not subsequent for what you're doing, you can always go back to the disassembly view. So you can use both interchangeably. And there is also the hex dump right here. So if you're like an hex person, then you can work from this. But I don't use this quite that much. So yeah, so that's that. I think there is one more view that is not enabled right here. So let me see if I can bring that up. Layouts. What the hell? All right, let me check that. Yep, the decompiler. So the decompiler isn't added, so I just right click and say show in decompiler, and it's showing the decompilation right here. So if you select the decompiler, it's gonna take some time to decompile. As you can see, it's gonna decompile the program. I don't really think anyways, let it do its thing. So we're just gonna wait for it to finish the decompilation, and then we're gonna continue. Alright, so it's done decompiling right here. So the decompiler is going to try to create some sort of C program, some C source code out of what it was able to analyze inside of this program. So essentially this is what it was able to come up with right here. And as you can see, it looks like a bunch of a couple of nonsense, but actually it kind of works sometimes. And you can select whatever decompiler you want. As you can see, by default it's using the Guidra decompiler. You can change that to the R2 decompiler, and you can see it actually decompiles differently from what we got earlier. So that's that. But in this video, we're not gonna be using the decompiler. There are several other uses for the decompiler, but in this video, we're not gonna use that. So let's just solve this program as quickly as we can. All right. And like I said, make sure you understand a couple of assembly language, so this is gonna be easier for you. So as you can see, the first thing that's happening here is this is actually gonna be a system call. And as you can see, one is being passed in here, so you can see that this is a one is being put inside of the EAX register. So you can see that this is gonna be a write syscall. How do I know that's gonna be a syscall? Because there's a syscall instruction at the end here. So it's moving 1 to tell us that it's gonna write something, I guess, and then it's moving another one inside of the EDI parameter. This is gonna be the file descriptor, I guess. Yeah. So if I want to confirm, I just have to do the I think no, I don't have to do that, do I? I just have to go back to, let me check if I have the man2 right. Let's check that out. Yep, that's what I want. Let me expand this. There we go. Yep, so you can see here the first parameter is the file descriptor, then we've got the buffer, and then we've got count. So that's gonna be put inside of the where the hell is it? Yep, here. So you can see here, so it puts the syscall number inside of the EAX register. Then the next thing it does is put the file descriptor, which is write. So 1 means write. The file descriptor is gonna be C out, standard out. So that is 1 is the constant for the standard output. So it's gonna write to the console, and then the message 1, MSG1, is gonna be what it writes to. That's gonna be the second parameter, which is gonna be the buffer. Let me check that out to be sure. So as you can see, yep. So the second parameter is gonna be the buffer, and the last parameter is gonna be how much store for writing. So as you can see here, you can right click on this and just say you can do set immediate base to decimal, and you can see that we're going to be writing 22. Alright, so that's what we're going to be writing here. You can double click on this. Let's see what happens. As you can see, it says no function detected. We should go back to the disassembly view and you can see what happens here. So what's going on here is that this is where we're checking, and it says here that enter your password. So this is what the user is trying to print out to the screen the first time. So we're gonna go back to the graph view. I'm gonna go back one. Let's do that from here. Yeah, there we go. So as you can see, it's simply printing out here, enter your password, and then it's calling the syscall whatever. And so here, what's going on here? Well, we've got 0 for the EAX. And let me quickly check to make sure of what the 0 is. I'm pretty sure the 0 is read. Yeah, I don't think there's no need to check that out, but I'm gonna leave a link in the description where you can have where you check out the syscall tables, so that you can know what the syscall instructions are and what parameters they go. I'm gonna leave a link in the description for that, so you can check that out. All right, so it puts the first instruction. So this is a read, so it's trying to read something, and then so whatever it's gonna read, so it puts 0 in EDI. All right. So what's that for? Let me check. Let me check. Read syscall. I guess that's what they call it. Read syscall. Yep. I guess. So let me just confirm that quickly. All right. Oh, let me see. Can I use this? Or I could have just done here man to read, I guess, to get what parameter gets passed into read. Alright, okay. So we get passed in the file descriptor. Alright. So 0 is the standard input, 1 is the standard output. You can see here 1 gets passed in because it's standard output. 0 is the standard input, and so that gets passed in here. And so the buffer, you want to store the data, that's what get passed in here. So let's check that out. So the buffer you want to store the data is passed into input. So input is going to contain whatever data that we pass inside of here. Obviously this buffer is going to be empty if you want to confirm. Let's check that out. Nope, there's nothing in there, so it's just there. I think this is like a let me check that out. Okay. Yep, input is like a pre-allocated space where we're gonna put our data, and then there's one last parameter. Let me just confirm that. The last parameter we have is count, so that gets put into the EDX register. So this is gonna be like 16, I guess. Let me confirm that. Yep, so this is gonna be like 16. So we're gonna put 16 bytes of data inside of the EDX register, and so it's gonna read 16 characters. So essentially what this means is that I don't know if I should enter more than 16 characters. I think this is gonna cause like a buffer overflow or something. Well, let me check that out before I continue. So let me run this and I enter something more than 16 characters. I think this should be more than 16, and it says wrong nonetheless. Oh, cool stuff. Actually, what happened was that it just I think it just breaks the rest up or something. Anyways, so that's that. So it just takes in 16 characters, and it calls the syscall and reads this data from the user. And so when we enter the password, the next thing that happens is that this password right here, so this is another variable. I think it's inside of this address, and it gets put into the RDI register. What the hell? Let me go back on that. Alright, so it gets put inside of this RDI register, and also the input which we got from here gets put inside the ROSI register right here. Alright, anyway, that's making sense. So so RDI contains the real password, if you know, because we put some variable right here, password. So it gets put inside of the RDI register, and the input we just passed in gets put inside of the RSI register right here. And then this is 11. 11 get, let's just convert all this just to make sure that everybody's seeing the correct values. So 11 is put into the ECX. Why the hell is that? Alright, now what is this instruction? REP. I really don't know what that instruction is, so we could just search Google for that. Assembly language REP, I guess that's what it's called. Yep, so let's wait for that to load, and then we're gonna find out. Let's just click something, I don't know. REP, come on. So let's wait for that to finish. And so we got REPE. I don't know what the instruction does, so let's check that out. Alright, this is taking too long. I think I'm just gonna go back from here. Let's see. Let's select this one. I think this one kind of makes much more sense. Alright, come on. Okay, it says repeat string operation preferred. So what the hell does that even mean? Oh, this is a lengthy description right here. Alright, so it says repeat a string instruction the number of times specified in the count register. Alright. So let's check that out. So we use the repeat while equal. Wow, that's cool. So it looks like they're comparing whatever is here. Okay, they're using the RSI as like some sort of counter, I guess. Yep. Alright. So it looks like they're comparing. Yep. That's what's happening here. So they're comparing what is in the RSI register with what is in the RDI register right here. So it simply means that they're comparing. So this is more like a loop. It says compare these two while there's something in there. If you look at the instruction right there, the REP, it says repeat while equal. Alright, so it simply means that repeat this instruction, while the values are equal to each other. So if once they're not equal, it means one of the values are not actually equal. Alright, so it's just gonna break out of this, and then it's gonna do whatever it wants. Alright, so essentially this simply means that repeat while they are equal to each other, and once it's done, it's just gonna continue. Alright, and I think what it's done is gonna set a flag here. So this is JE, and JE simply means jump if equal. I don't know if I can show you guys that to confirm. I don't know if that's necessary, but anyways, you can go check that out. JE simply means jump if equal. So if these two values are equal to each other, then it's gonna jump to the correct func. Oh damn it. Alright, so it's gonna jump to the correct func right here, which is let me move that correctly. So as you can see here, this is green, so this means this is the correct func. It's also highlighted here. If not, so let's see. If it jumps to the correct func, then this instruction here is just gonna move on to EAX. Whereas if you see syscall down below, we're pretty sure that we're trying to write something to the screen. Cool. So it's gonna put one to the EAX, to the output file descriptor. It's gonna print something correct. I think it's gonna be correct. So we need to find a way to get to this correct message. So that's exactly our purpose in this video. We're gonna try to crack this stuff. We're gonna need to get to this correct message right here, and then it's gonna print that out, and that's gonna be it. So it's also moving 60. If you I think it's already been put here, but let me just convert that to decimal quickly. So it's also going to take 60, put it in the EAX, put 0 in the EDI for 60 is simply the exit syscall, 0 is the return code, and then it's going to call syscall to exit the application. Alright, so that's what that is. So it's going to exit that, and as you can see, this is if we have the correct function. So if it wasn't equal to each other, then it's gonna print wrong. So if you look at what we've been doing, if we were to do press the wrong password, as you can see, we've been getting wrong. So this is where it happens, because these values are not equal to each other. So what we want to do is to make sure that these values are equal to each other, so we can get to this good boy right here, because that's what we call it. So we want to get to the good boy right here. So how do we do that? Well, what we have to do is to get the value of what is here, this password. And in this video, in this particular example, it's kind of really simple. All we have to do is to in Cutter, just have to double click on this and see where it takes us. As you can see here, it says no function detected, so we're gonna have to go back to the disassembly view here. And if you go to the disassembly view, you're gonna see that password simply points here to correct, wrong, super secret, and all of these are terminated by new lines. Alright, so it looks like what we're looking for is somewhere along these lines. And I'm gonna bet that the super secret text is gonna be our password. Come on, I think it looks catchy enough, right? So maybe we should try that and see if we're gonna get the correct stuff. Alright, what do you think? So let's go back in here and type in super secret. And we got correct. Okay, that looks cool, right? Well, yeah. Wasn't that hard, was it? So, yeah, we just solved the problem and we are good. Let me go back to the, what is it called? I can't do that. Come on, I can't do that. Oh, yeah, there. So, as you can see, we just solved this very simple problem using Cutter, and so that's gonna be the first we're gonna do in this video. In the next video or in subsequent videos, we're gonna be solving more Crackmes and we're gonna be analyzing all those things together. I hope I see you guys in that video, and take care of yourself, please. If you like this video, leave a like, subscribe, and subscribe to see more videos, and I'll see you guys in the next one. Take care.